Yeah, good afternoon, everyone. I hope everybody had a good lunch. I know this is the last, this is a bad time or the dangerous time to do presentation because some people will be sleeping. But please bear in mind that we have two online presenters who can see you sleeping if you sleep. So we have a card here, and if it's 3 minutes, we're going to show you the card. And if it's 30 seconds, we're going to show you the card as well. So the time for the presentation is 8 minutes. Okay. Since the people online did not have their lunch, they will start first. So we give them the opportunity to start. So the first presenter is going to be Carlota Lopez. Sorry if I don't pronounce your name very well. Yeah, so she's going to present online, and she's the first presenter. Hay que compartir. Seguro. Sí, ella no, no yo. Yo creo.
¿Lo comparto yo?
No sé. Sorry for the technical problem.
Que la comparta ella, ¿no? Vale, la comparto. Sí.
You can kindly share your screen and start the presentation. Okay.
¿Se ve?
Yeah. Full screen. Perfect.
¿Y nosotros?
Nosotros nada, yo creo. Nada que hacer.
¿Empiezo?
Yeah, you can. Please, you can start.
Okay. Today I saw the main results of my bachelor thesis. My work focuses on quantifying the carbon balance of a dehesa system in the Western Iberian Peninsula using a direct dendrochronological approach. Mediterranean dehesas are multifunctional agroforestry systems with high ecological value. They are often considered important carbon sinks, but their real contribution to climate change mitigation is still uncertain. One of the limitations is that carbon balance is frequently estimated using indirect approaches. In this study, we use dendrochronology as a direct method to reconstruct tree growth and quantify carbon sequestration. The main objective is to evaluate the role of a real dehesa system as a carbon sink using this technique. The study was carried out at the El Sestil study site located in Salamanca. It's a 345-hectare private dehesa, and the tree layer is mainly dominated by Quercus cucusiles, Quercus pyrenaica, Quercus pagina, and Fraxinus angustifolia. It's also managed under extensive livestock race, livestock density of 0.28 livestock unit per hectare. It represents a moderate grazing pressure and reflects a real productive dehesa system. I will now focus on the forest structure of El Sestil, which is key to understand its carbon sequestration capacity. Forest structure is a key factor controlling carbon sequestration in the dehesa systems. El Sestil shows an average tree density of around 50 trees per hectare and a basal area of 8.4 square meters per hectare. The diameter distribution indicates a mature structure, with most trees concentrated between 30 and 50 centimeters in diameter. This high proportion of large trees explains the high carbon sequestration capacity observed in this system. At this point, the key question is how the tree growth is translated into carbon sequestration. We use dendrochronology to measure annual growth. Annual growth was converted into biomass increment. This biomass was then converted into carbon and expressed as CO2 equivalent. This allows us to quantify annual carbon sequestration in the Sestil dehesa. And now I will represent the main carbon sequestration results. In this slide, we can observe the annual carbon sequestration by tree biomass in El Sestil from 2007 to 2022. The average sequestration stands at 1.71 tons of CO2 equivalents per hectare per year. However, as the graph shows, there is a significant interannual variability. We found a strong correlation between precipitation and carbon uptake. During severe drought years, the sequestration capacity drops dramatically. This highlights that while these systems are powerful sinks, their efficiency is highly dependent on water availability in a climate change context. To determine the net balance, we must analyze all components of the system. On the emission side, the livestock management at SST produces around 616 tons of CO2 equivalents per year. However, we have two powerful carbon sinks. First, tree biomass, which as we saw, captures 590 tons annually. But the most significant finding from the updated data is the soil sprawl. With a sequestration rate of 3.54 per hectare, it captures over 1,550 tons per year. This highlights that the soil is the largest and most active carbon reservoir in GTSA. The final net balance, when we only consider trees, we offset about 75% of the emissions, which is already significant. The key factor is the inclusion of the soil component. By accounting for the soil sequestration, the total capacity jumps to 283%. The farm captures nearly 3 times more than it emits through livestock management. And why is our result so much higher than previous studies? For example, Reis Palom reported a tree sequestration of only 0.26 tons per hectare. In contrast, our direct measurements at El Sestil shows 1.71 tons per hectare for the trees alone. This difference, coupled with the crucial integration of the soil sink, demonstrates that major well-managed DSAs are massive net carbon sinks that far exceed standard estimates and a vital tool in the fight against climate change. Thank you.
Thank you so much for your presentation. So we'll move on to the second presenter or the second speaker, who is, sorry if I don't mention your name very well, Nicole Ivano. And you can start.
Hello, everyone.
Okay, go ahead, please.
As I said, my name is Nikolai Ivanov. Well, as they said, my name is Nikolai Ivanov, and I will be presenting my work, which is on different phenotypic plasticity for male and female reproductive allometry among Pinus pinaster providensis. And this was done basically to answer the question, how does reproductive investment scale with tree size across contrasting environments? As many of you know, Pinus pinaster is a Mediterranean conifer with wide geographic distribution that occurs along very strong environmental gradients with high genetic diversity and pronounced phenotypic plasticity. Its reproductive allometry links reproductive investment to vegetative size and often reveals trade-offs between growth and reproduction in long-lived trees. And this tests how reproductive allocation scales with size. The conceptual framework of these studies was done via two common garden trials, one at Ibias, Asturias, which has more Mediterranean-like and unfavorable conditions with a steeper slope and lesser soil size. And later we have America in Galicia, which is way more Atlantic, has more precipitations and overall more favorable conditions for the species. We tested 25 populations spanning their species' natural range, and we tested the traits for height, diameter at breast height, and male and female reproductive onset. Now, for results, in height, we consistently see higher traits in America rather than Ibias across all years, confirming the expected environmental effects. We see that provenances show largely parallel growth trajectories, indicating limited rank changes and weak provenance and site crossover for height. And differences among provenances oftentimes become more pronounced over time, particularly at the high productivity site. For male reproduction, we see it is very tightly coupled to vegetative size, and this relationship is remarkably conserved along sites across sites and provenances. Although we do see clear side effects, these are largely mediated by growth differences rather than changes in allocation. In other words, male function responds rapidly to environmental productivity through site rather than through population-specific strategies. And for female reproduction, unlike male, It shows delayed onset, steeper and more variable scaling, and clear population-specific responses to site productivity. This suggests higher resource thresholds and strategic divergence in female allocation. And for the conclusions of our study, we see that growth is mainly plastic, environmentally driven, which is something that was easily intuited, and male reproduction is size-dependent and conserved, while female reproduction reveals adaptive divergence and strong genotype by environment effects. Thank you for your attention.
Thank you for your presentation, and please stay tuned because after there'll be questions coming in. So now let's move to Alba Magaso. Sorry for your name.
No,
okay, let me quickly bring. Sorry. Alguien que pueda hacer. Porque normalmente no completo.
Ya.
¿Es un PDF?
Sí. Había que pillar un PDF, ¿no?
Sí, sí, es posible.
Si no voy bajando.
No, tiene que haber aquí. ¿Perdón? Pues vuélvelo a... ¿Cuál es?
Ese.
Joder, no.
Ya, lo tengo que poner.
¿Este?
Ese, sí.
Así no.
Modo pantalla completa.
Sí. Va, venga, ahí.
Gracias. Good evening to everyone. I'm Alba Magarzo and I'm a PhD student in a company that is located here in Palencia. It's IDE Forest. And today I'm going to talk about the main topic of my thesis, that it's about bacterial facilitation of early mycorrhiza formation in black truffle seedlings. So one of the most valuable fungi is Tuber melanosporum, that is the black truffle, and its geographical distribution is mainly in the Mediterranean countries, mainly in Spain, in France, and in Italy, being Spain the main producer worldwide. Its production is mainly made in plantations that are controlled, and in some places the benefits that they can make are bigger than any other forest product. So one of the main things that we have to ensure for a plantation is the quality of the seedlings, and these seedlings comes from nurseries where they have been previously inoculated with Tuber melanosporum, and we have to ensure that the percentage of mycorrhization is higher in order to ensure the future production. And we also know that in the interaction between the plant and the fungi, there is a third element that are the plant growth promoting rhizobacteria, known as PGPR, that are the bacteria that lives in the rhizosphere, that is the soil that is surrounding the roots, and they can enhance the plant growth through different mechanisms. And these mechanisms are mostly nitrogen fixation, phytormone production, pathogen-induced resistance, and improving the nutrient availability. So knowing this, the objectives of this study were to isolate bacteria from soils of high-yield black truffle plantations, to evaluate their PGPR potential, and to assess their application from improving the production and quality of mycorrhizae seedlings. So what we did was to take soil samples from different plantations, from high productive plantations in the natural distribution in Spain, in order to try to relate this high productivity to the bacterial communities that are linked to these soils. Once we had the samples in the lab in control conditions, what we did was to isolate the bacteria, and once they have grown, we selected them by morphology until we had pure cultures. And once we had these pure cultures, we started to perform the PGPR activities that basically what we did was to inoculate the bacteria in different media in order what we wanted to check. For phosphate solubilization, what we did is to inoculate the bacteria in a media with insoluble phosphates, and to check if the bacteria was able to solubilize it, what we saw was the change color of the culture media from blue to white. In the case of auxins, that is the hormone that promotes the root growth, what we saw is the change color from yellow to orange or pink. For nitrogen fixation, we inoculate the bacteria in a media without nitrogen, and if the bacteria was able to grow, it's because it was able to use the atmospheric nitrogen. And for siderophores production, that what we wanted to check is if the bacteria was able to use to catch the iron that is in the soil. What we saw is also the change color from blue to orange. And once we did this, we started with the nursery trial, and for this we started preparing the seedlings inoculated with tuber melanosporum. The three species that we chose was Quercus ilex, as is the most used in truffle plantations, and then we performed the bacterial inoculation choosing the 4 best bacteria. So what we chose was the best bacteria for each PGPR activity, and then a pool of the 4 of them. And in the point that we are now, we are evaluating the mycorrhizal colonization. We are analyzing the growth of the plant and the percentage of mycorrhization after 7 months. So once we have done this, we are going to know better the interaction that is between the plant, the fungi, and the bacteria that is associated to it. And what we are going to do is to improve our understanding of native bacteria in truffle crop soils, and we could be able to use a resource that naturally is present in these soils. And I would like to thank the Foundation, the IDEFOREST team, and also the Myco-Infor team, and of course you for your attention. Thank you.
Thank you for your presentation as well. Now we go to Jorge Miestre.
Well, hello everyone, I'm Jorge Maestre, and today I'm going to talk about how competition structure drives drought resilience in a super-Mediterranean pine forest. First of all, there's I hope no one is surprised to hear that Mediterranean forests are getting increasingly exposed to fatal droughts, and also that the pine forests are a vital ecosystem in the Mediterranean basin. And so we need to adapt our management to face this challenge. Here we already talked about mixing as a way to find the overyielding, the stock overyielding, but also to reduce competition and maybe through that reduction in competition, we may boost drought resilience. Also, the development of resilience indices has been well. We have seen a lot of papers using this kind of resilience indices. The first one of them was the Francisco Lloret from 2001. We are going to discuss it later. So basically, to understand the tree response to drought on mixed forest and to adapt our management, we are going to use in this work dendrochronology. So basically, we have a 1 hectare plot with 757 located and measured trees, where we extracted the 2 cores per tree. We selected the drought index, the drought events with attending to the SPAY index, and also we calculate for each one of them the HEGI competence index, and we also decompose this HEGI competence in intraspecific competence and interspecific competence. Competition, not competence. I already talked about the Francisco Lloret paper, and since then there has been a lot of papers using that indices, and also some of them that criticize them, and also some of them that propose new ones. Today we are going only to talk about the classic resilience by Francisco Lloret, but also the growth resilience index proposed by Tom Ovenden in 2021, that it consists in the forecasting of growth through an ARIMA model and the ratio between that forecasted growth and the observed growth. Also, our team, we tried to develop a new index called Growth Years Lost, based on Eric Thurm paper from 2016 that consists on the growth recovery time and the expected and observed growth during that growth recovery time. Also, to understand everything, we use the GLM TMB models and the Akaike information criteria. Basically, what we found in the classic resilience indices is that it's modulated along a competition gradient. What we see here is there's in the left side we see the scenario where the competition is mainly interspecific. Only 25% of the competition is intraspecific, and on the right side we see the case where the 90% of the competition is intraspecific. And inside every chart we see the competition gradient. They behave similarly, even regardless of the composition. But what we can see is that in every case, Pinus nigra is always a more resilient tree than Pinus sylvestris. When we take a look at the growth resilience index by Tom Ovenden, the results change a little bit. This time, Pinus sylvestris is more resilient than the Pinus nigra, and also what we see, and it's really surprised me, is that in high intraspecificity and high competition scenarios, the growth resilience increases. And also, when we take a look, the index is a little bit different because we have to understand that the lower the value of this index, the better. So basically what we see is that the behavior of both species change, the behavior of Pinus sylvestris is similarly whether the competition is intraspecific or not. But what we can see is that Pinus nigra behaves better in more intraspecific occasions. Basically, what I think you can appreciate that both indices are looking for a complementary response, where they show that both scenarios where high intraspecific competence maximizes resilience. as it may look in both indices that Pinus sylvestris is more resilient than Pinus nigra. Basically, what I want you to take home with this presentation is that we need to use more than one index to understand what is the drought resilience, especially the individual response. Also, I believe that gross years lost may be a good index to implement in stand modelization as a way to relatively account how much we lost in terms of growth with a drought, and also that the effect of mixing on individual response remains unclear as different indices oppose in what they signal, right? Also, that Pinus nigra modulates its response different to Pinus sylvestris, and it was discussed later, mixed stands may be more resilient, but if it's the case, other processes other than competition reduction may be the ones involved in the boost observed in these mixed stands. So basically, thank you for giving me this opportunity to talk in front of you, and that's everything I have to say.
Great, very nice presentation. And we'll move to the speaker, Rodrigo Garcia. The floor is yours.
Okay, thank you. Okay. Thank you. Okay, I'm going to present the project called Integrating Airborne Laser Scanning Data, Topography, and Climate Metrics for Fuel Mapping in the Western US. This project is being developed at the University of Valladolid at the Soria campus in collaboration with the United States Forest Service. Mapping available forest attributes is becoming increasingly important to support wildfire management strategies. And using airborne laser scanning data, we can characterize the structural attributes for forest stands, which significantly improves the quality of the maps. In this project, we develop predictive models based on airborne laser scanning data combined with topographic and climate metrics to map key forest attributes. These models allow us to generate wall-to-wall maps of forest attributes at a regional scale with a spatial resolution of 30 meters. The final goal is to provide accurate and actionable maps to support monitoring of ecosystem conditions. The study area covers the western United States and includes 11 states: Arizona, California, Colorado, Idaho, Montana, Nevada, New Mexico, Oregon, Utah, Washington, and Wyoming. And this space is 6 times larger than the Spain area, no? And in this area, we have a total of 605 LiDAR acquisitions, a total of 12,881 plots with ALS data collected within a maximum of 3 years before or after the field measurements. Here you can see a simplified workflow summarizing the main steps of the project, and using the field data, we first create canopy profiles and plot level attributes using the IFBS and FIA database. By combining field data with the auxiliary datasets, we obtain a very robust dataset that is used to train the models. And once the models are trained, we can generate predictions for the different variables of interest, which I will show you in these following slides. The models. Okay, the modeling process was carried with random forest algorithm with a data split of 70% for training and 30% for validation. Before building the models, we first remove highly correlated predictors to avoid potential problems later, and to ensure the optimal variable selection, the vsurf package was employed to identify the variables with the highest correlation. The models were grouped into three main categories of variables, are biomass pools, canopy fuels, and other structural variables. And I'll start with the biomass pools. We consider three biomass variables, above ground biomass, below ground biomass, and leaf tree foliage. And all of them show a fairly strong R-square values, with the highest performance for below ground biomass. Okay, in the graphs on the left side, we can see how the data are distributed by comparing the observed values versus the prediction for the best and the worst model in the group. Now we move to canopy fuels. We consider four variables in this case. The highest R-square was observed for canopy height and the lowest for canopy wool density. And on the left we can see the graphs comparing the observed versus the predict values for these two variables. And now we look at other structural variables, and we have three modeled, and the highest R-square is for maximum height and the lowest is for quadratic mean diameter. Here, as can be seen in these previous slides, the variables with the highest R-square are all related to the height. This is due to the large correlation of ALS data with the tree heights. And on the other hand, the variables with lower R-square are the leaf tree foliage, canopy wool density, and quadratic mean diameter. They are not depend on the tree heights. And now let's look at some visualizations of the prediction for different variables. We can see in this slide a specific flight work. On the left we have canopy wool density, in the middle canopy height, and on the right canopy base height. Mapping these attributes is very important because they provide the canopy fuel attributes required by various spread simulations. For example, like flat map is one, and the maps we create will allow for fire scientists to develop regional fire simulation and assessment. This is the entire study data. Shows the predictions look like across the western United States. When looking at the map, we can see that prediction follows the no vegetation gradients in the study data, with salarial accumulation on the northwest coast and the less fuel accumulation in the southeast. Arizona and New Mexico have areas of desert. And that will be all. Thank you so much.
Thank you for your presentation. So we move to the next speaker, who is Alicia.
Good evening, everyone. I'm Alicia. I'm a data forest student, and I'm going to present the investigation I'm carrying out because of the bachelor thesis inside the Smart Ecosystem Research Group and under the supervision of Aitor Vázquez Veloso and Felipe Bravo. You might be thinking right now, why high diameters equations? Why are they important? Well, they allow us to estimate the height of a tree. That is the base in forest management plans. But that measurement is always so costly and it takes so much time. That's because this research is important. So, as I said, right now, the forest management planning is based on them, not to tell the timber volume estimation and its economical and ecological benefits. We are sadly into a climate change content and the forest management strategies that have been modified during the history of forest management. As you can see in the graphic below, the comparison between height and diameter classics in the different editions of the Spanish Forest National Inventory. So our approach is to find new height diameter models for the studied species, which are Pinus nigra, Pinus pinaster, Pinus silvestris, and Quercus pyrenaica, and as a specific objective to compare both the new models and the current one to search for the errors in the estimation of wood. My study area is located in the north of Palencia, where the agricultural lands transition into the mountain area. We are in Castilla y León, for who are not from Spain, we are there. And we extract raw data of height and DBH, which is the height at the pressed, okay? And we combine both the administration plots and the Spanish Forest National Inventory from the plots nearby. I have to take a note that it has not been taken into account whether the stand is pure or mixed, okay? Even though if we have 4 species. So the methodology I take is to try to get that data set adjusted to 95 models with the help of an R script, and to make the decision of which model do I pick, I use the statistical metrics of root mean square error, Akaike criteria, mean bias, and R square. And then we just follow the objectives. The results I get are quite visually fantastic, I would say. But sadly, the metrics are not that good compared of the current model. And this expands into also Pinus nigra, Pinus pinaster, Pinus silvestris, and Quercus pyrenaica. So, my conclusions is that I don't have conclusions. Choosing is the first step of this research, and the next one would be to add stand variables to this equation, these models, to try to improve those statistical metrics with, I don't know, maybe bathymetric area, maybe high dominance. I need guidance. Thank you. That's it.
Great presentation. Last but not the least, our speaker is Sayowa. Okay, the floor is yours.
So good evening, everyone.
I'm going to present our work entitled Satellite-Derived Vegetation Indices and Radar Metrics as Proxies for Tabermelanosporum mycelium Dynamics. Our work is part of the Taberlinks project, and we carried out with researchers from IRTA in Catalonia and CSIC in Madrid. And the main goal of this project is to optimize truffle orchard management by studying the soil plant fungus complex. So, as Alba said before, the black truffle has a very economic and gastronomic importance in our country, and Spain is a global leader in truffle production. So enhancing its cultivation is vital for the rural and the country bioeconomy. So the integration of remote sensing in black truffle studies has never been explored before. So this is why our project is very innovative. So we ask ourselves a simple question. Can remote sensing provide us indirect information about black truffle mycelium activity? So our idea was to look for signals that can reflect what is happening underground. So the main objective of this work was to explore relationships between remote sensing optical and radar metrics and the black truffle mycelium biomass. This study was carried out for several truffle producing regions in whole Spain, as you can see there in the map. I have to say that we had a highly valuable ground truth data, that it is quite important in this work. And we employed a total of 492 samples. Each sample refers to a single tree, and we also took, or there were taken soil samples with the milligrams of mycelium. And these samples were divided into truffle managed plantations that were 288, and hallmark natural forest that were 204. And also these old samples were collected for 4 different campaigns that are where the maximum peak of mycelium is, that are the autumn of 2019 and 2020 and the spring of 2020 and 2021. So we followed this methodology. We employed images from optical sensors that were the high resolution PlanetScope and the Sentinel-2, and we calculated optical indices for these 2 sensors. We calculated the NDVI for the PlanetScope and the NDVI and several moisture-related indices to the Sentinel-2. And later we employed Sentinel-1 images that are radar images. And we extracted the backscatter values for these images that in 2 different polarizations that were VV and V8. We extracted all of this data for a buffer of 50 meters around each tree, because the mycelium spreads around the tree and we wanted to see what is happening with the mycelium. And then we related these values with the milligrams of mycelium. So we also included geographic factors in the study. We included the altitude and the region. In the altitude, we divided samples into 3 different clusters. One below 700 meters, another one between 700 and 1,000 meters, and another one above 1,000 meters, as you can see where I distributed in the map. And there also we divided into different regions, in one of the Iberian system, another one the Ebro Basin, and another one the Pyrenees. So our main results are the for planet scope sensor that we have limited explanatory power, except for the spring, that we had a significant relative negative relationship between the NDVI and the mycelium. For the optical sensors, that would be the Sentinel-2 sensor. Also, we had a limited explanatory power, except for moisture-related indices that slightly go better, but they weren't significant. So, in contrast with the radar data, surprisingly, we had a significant negative relationship with the mycelium biomass that was higher in the spring. We saw also that the mycelium biomass increased with the altitude. That was surprising. And the region showed no clear pattern. So as you can see here in the graphs, the green points represent altitudes above 1,000 meters, and they are related to higher amounts of mycelium, and also the radar values, the backscatter values, are lower. So this is the main relationship. So our main conclusions are first that radar backscatter outperform optical indices in explaining mycelium biomass, that mycelium biomass showed a strong altitudinal pattern, that it was higher at a higher altitude. Radar signals likely capture soil moisture-related processes linked to fungal activity. And finally, that radar data are a valuable proxy for studying below-ground biological processes. Thank you very much for your attention.
Thank you, all speakers, for your presentations. And now we'll move to questions and answers. So anybody who have questions, you can go ahead with your questions. Thank you. Please feel free to raise your hand. Okay, thank you.
Hello. I would like first to congratulate the presenters for their presentation. I have the same question for Alba and Jorge. You presented your work. You said that you have observed some samples. For Alba, it's a soil sampling, and for Jorge, other type of. But you didn't say anything about the sampling methods you use it. We know that the analysis process is depending on the sampling methods, how you have, and we also have to observe some strict considerations depending on the heterogeneity of the study area. That's which we should absolutely find the best way to observe. What were your sampling methods?
No. Well, thanks for your question. Well, I try to summarize that part, because I explained that last year and this year I wanted to focus on the nursery trials more and the part in the lab. But yes, of course, the sampling design is really important in this case. And what we did was to choose different plantations where we know that the productivity was really high. And then in that plantations, truffle producers know quite well where are the parts of the plantation where the productivity is higher. So we took samples there in the parts that we knew that the productivity was higher in trees where they were really good producing truffles. And all the plantations were of the same age. That's quite important also for the truffle production. And to take the samples, all the material was sterilized, and we took the same volume from each tree, and that's all, more or less.
I'm asking especially about the sampling strategy, for example. Have you but you are explaining that, and I think that you used stratified random sampling. That's what. Yes, you have to specify the stratified because you choose some plantations first, having the same, how to say, characteristic, and then within this plantation you choose the soils. Within this plantation, have you been able to choose your soil samples randomly within each plantation, or you choose subjectively your sample?
No, we choose, well, it was chosen randomly inside the areas where we know that the production was high.
Basically, in my case, we had a 1 hectare plot that was ubicated there a long time ago by previous projects. Then every single tree was located with submetric precision, and that's I mean every inventariable tree inside that plot, and then we take the measures of altitude and diameter and all that kind of measures, and finally we extracted 2 cores with a Pressler Navarrena. And basically that was everything. Then we analyzed every single one of the cores, and basically that was the sampling method. Not much to say.
Thank you. I have a question for Rodrigo. But before, I want to congratulate you for your presentation and promising output that I'm sure next year will be more consolidated, because every year we have better results. Rodrigo, regarding your topics, you talk about canopy bull density, and I'm wondering how you estimate that density in the canopy.
Okay. Thank you for the question. The canopy bull density, it's a variable who estimate the density of the biomass of the canopy, and this data come for me from the Forest Service, and it's from the FBS simulator of the Forest Service, and the database comes to from the FIA database.
I was wondering, I assume that then they obtain that value from biomass equation for the different species. I don't know. But I was wondering if you obtain the density through the point cloud density from the LIDAR. So if you got the canopy, extract the canopy and they count the points, or at least sample in the point cloud the canopy to get an estimation of the point per unit volume.
No, I take all the metrics of the LiDAR and I predict with them. I don't know what is the relationship directly, but it's something statistic.
Yeah, but I think that this is important, because you have to understand where your data come from, because maybe you are taking for true something that is in some way is weak. So I think that the definition of the variable that you will use to predict, or you try to predict with the LiDAR, is really important. Thank you.
Please feel free to ask more questions because we have some time.
Yes, I have another question for Rodrigo. You worked mainly with the ELS data.
Yes.
Trying to to estimate the values of some attribute for trees, and also to identify the fuel biomass.
Yes.
Do you think that ELS data are enough for this study?
No. I used ALS data, topographic data, and climate metrics.
No, I'm not talking about, yes, those are all other variables, but ELS and TLS. You don't have TLS, I know that, because it is a lot of, it's a big data set. And have you at least have thought about in some places of this, try to find, to have this TLS data? Because, for example, DBH or some diameters or some attribute are not very useful to find or to estimate using just ELS data.
Yes, but I used this database, and I used two field measurements, and with these field measurements, I do a simulation of variables of interest, and with this product, I do the predictions. The models and the predictions.
Another question for Alicia. Just to discuss, it's not you were trying to find a new diameter.
The what?
Okay, you were trying to find a new diameter.
No, just a new model.
Height?
Like the equation of height diameter uses the diameter to estimate the height.
Yes.
So that's what I'm searching for, like a new model.
Okay, that's it.
Yes, for clarification, I want to ask Alicia, why, so the question from Professor Muni, why is so important, or why we need new models when we have already models to predict height from the diameter? So, because you mean that normally we don't measure any height, we try to measure any diameter in the tally trees, in the trees that are in the inventory, but not every height, so we have to predict. But we have already this kind of models, and the problem is that the model don't work very well. Right now. They are not doing good prediction, and then why? Why the models are wrong now, and one is needed your job. I think that is one of the things that are missing. For that reason, Professor Muni maybe don't understand what are you doing.
Because climate change has varied the relationship between height and diameter, so there's an error in the data. Like it was like in the graphic of the Spanish Forest National Inventory comparison.
And
last question for yeah. You try to use optical waves and radar waves to determine how to say miscellaneum, but in my opinion, optical was obvious that it will not give any good result. That's my opinion. But you find good result using radar, and which kind of wavelength it was most effective for this modeling?
Wavelength.
Yeah.
O sea, sorry. You're referring to the C-band of radar. That's what that Sentinel-1 is using, the C-band of the radar. You are meaning of this? Yeah, they are different, like the L, A, X, but this one was the C band that it's used for the vegetation normally, and it's the band that Sentinel-1 is working. So that's the band.
Okay.
That was your question.
Okay. We still have 2 people online in case they want to say something or ask a question. So we have not forgotten about the people online too. Please, if you have something to say, Lopez and Ivanov, you can unmute yourself and say, if you have a question or something to say. Okay, I'm sure they have nothing to say then. Okay. Any more other questions? We still have maybe 5, 8. Okay. Okay. I think I'll go for one question while some people are thinking. I think you mentioned about the competition indexes you use in your work. You use only Hinge index, but your take home says that. So my question goes to your work, saying that your take home message was that multiple competition indexes should be used, or is best.
Yeah, for sure. I hope in a future we could use LiDAR images that measure the structure and how, and not only the Heki index that is, well, it's easy to use. That's why we use it, and that's why we can present it today and not the next year, because we hope that with the progress in the making of new indices that may be more precise about how different individuals interact, we may, you know, advance in this topic now. But basically, by now, just the Heki index.
Okay, thank you. Any other questions from the audience? No other question. Okay, I think we need coffee, so let's take a quick break. But before we do that, let's give a hand of applause for the speakers. Okay, can you please come and give your last speech?
So now it's time, as Eric says, for coffee. But just remind you that we welcome excellent high school students today, and they will present their posters. So be talkative to them and go to their posters, and also try to also talk or see the other posters, the general posters that we have in this conference. I remind you that we have this paper with this table, so you need to fill. This table is for both for the best poster award that we will have by tomorrow. BS students are not included. They will have their own award this evening. Okay? But for the rest, we need to vote, and to get a valid vote, we need that you collect 3 signatures from 3 different presenters at least. Okay? See. They can vote as well, so you can take this paper in the entrance, but I think you will be really busy just presenting your poster. But if you have time, for sure, you can talk with other researchers here and also vote it. Okay? Is it clear for you? Good.
Hola, ¿nos oyes, María? Sí. Ah, te oímos también. Vale.
Sí, aquí se te ve también.
Que el problema no es de ellos, el problema es que desde aquí no podemos, pero va a funcionar.
Tienes que me suene también, ya está.
In the Moodle, in both subjects, three assignments where you will have to upload the presentation, the abstract, and the poster. We'll put there as an assignment. We'll put for Friday afternoon deadline. And so everyone, I will send you also a message, but just in case I want to say you here. 3 assignments will be uploaded in the Moodle, ordinary class subject assignments for the Moodle Medfor students and Seminario de Investigación students. So be aware to upload just the presentation you gave them here, the poster you just printed, and the abstract you just sent. We have to upload it in the platform as assignment for having also for register. Thank you.
Now we will proceed for the BA award. So please, Fuad and Pilar.
Thank you. Okay. Before announcing the winner, I just want to say that it was a tough task. Try to find which the best, and in my opinions, you are all good. I had very difficulty to find the best presentation, the best poster between you, because you are all of you did a good job, and you explained it. I heard every one of you, and you were really persuasive by your explanations, and I encourage you to go further in this way of science and research, and I hope you a good future in your study and in all your life. Then, because it's necessary to find one of you, because they don't have how to say present for all of you, then the winner is Mr. Sergio Maro Andres. And the poster, it was Urban Tree Allometry and Ecosystem Services. Congratulations. But you are all of you winners. Don't be okay upset about this. Okay, thank you.
Good afternoon, everyone. So first of all, thank you for still being here. We are going to start with the last session of the day. So please welcome our first speaker, Andrés de la Cámara.
Hello, can you hear me? Can you
Yes.
hear? Yes?
Yes,
Or
yes.
not? Okay, so I start. Well, hello to everybody, and thanks to the organization of the Congress. I'm Andrés de la Cámara, and I'm currently working on EC4 in IA, and I'm going to talk you about the effect of thinning on growth response to drought on Pinus pinaster in mixed Quercus pyrenaica stands. Well, climate change is posing a severe threat in Mediterranean forests, mainly through the increasing of frequency and intensity of drought events. These droughts are not only affecting tree growth and mortality, but also biodiversity and key ecosystem services such as carbon sequestration. In this context, mixing species stands and thinning treatments are proposed as adaptive management strategies to improve ecosystem resilience and resistance. Mixing species can benefit from resource complementarity, and thinning can reduce competition for water. However, although short-term effects of thinning are well known, we still have a limited understanding of how these effects change over time, especially under repeated increasing drought events. In this study, we focus on Pinus pinaster. It's a light-demanding and pioneer species growing in mixture with Quercus pyrenaica. It's a more shade-tolerant and typical of later successional stages. And our main objective was to evaluate how the effect of thinning on growth response changes over time in Pinus pinaster. So for that, the study was conducted in Lluvia, Soria, in central Spain, and the plots are about 1,100 meters above sea level and under a subhumid continental Mediterranean climate. The stand is a mixed forest, as I said before, of Pinus pinaster and Quercus pyrenaica. And the current structure results from the reintroduction of the maritime pine after harvesting and soil preparation in a previous oak coppice stand. And now, as a result, pine is managed as a hide forest and oak as coppice. And for the study, in 2009, the treatments that is the thinning was placed in 3 triplets, each one with 3 plots. One was no thinning of the control, the other one was moderate thinning, and the last one heavy thinning. That 3 times. So, increment cores were collected in March of 2025, and they provided a 16-year-old growth series coring before and after the thinning, and a lot more years, but we don't use it. We calculated basal area increment and identified the drought events through the standardized precipitation and evapotranspiration index, the SPA. And we identified 3 major droughts that were 2012, 2017, and 2022. And then For each drought, we computed drought response indices, as our mate said before, from Jared, the resistance and resilience index, and then from Thorm, the recovery period index from the point rest package in R. Finally, we tested the effect of thinning on these indices using generalized linear mixed models. So here we have the main graphs and the main results of the models, and the effect of thinning was clearly differed among the treatments. During the 2012, in all the graphs is the green graph, which occurred. Remember, the thinning was in 2009, the drought 2012. It occurred shortly after the thinning. And we can observe that thinned plots showed higher resistance, higher resilience here, and less recovery period. So the thinned plots recovered more faster compared to the unthinned plots. This indicates a positive effect of thinning in the short term. But in contrast, during the 2017 drought, thinning had no effect in the resistance, but yes, in the resilience and in the recovery period. While the thinned plots had less resilience and recovery, more time to recover after the drought in the thinned plots. And finally, during the 2022 drought, there was no effect even in the resistance and in the recovery period. The resilience we couldn't calculate it because we didn't have enough time. So the conclusions. Well, these results indicate that the effect of the thinning growth response is not constant over time, and it depends either in the time elapsed since the intervention and also in the drought conditions of the characteristics of the drought. Here in the right, we can see the three different droughts, and as you can see, in 2017, the drought was completely in the growth period, and also in the cumulative drought of 1 year and 2 years, you can see that the 2017 was the biggest drought. So in the 20 and 12 response is, as I said before, is consistent with the results release effect. So the reduction of the biomass, the trees, reduced the competition and gave more water availability to the trees that were there. However, in 2017, the drought was more severe, and also we had another 2 droughts before that were not in the scale to be really good, really vast droughts to put it in the analysis, but we used 2017. And we think that by the time the thinned plots, the pines developed larger crowns and possibly a higher leaf area to sapwood ratio, which these adjustments enhanced the growth under favorable conditions, but increased the transpiration. And as a result, under prolonged and more severe droughts, the trees in thinned plots became more vulnerable, showing stronger growth reductions. And in summary, our results show that thinning can increase resistance, resilience, and reduce the recovery period in the short term, but it may increase the vulnerability to severe and prolonged droughts. And that's all. Thank you so much.
Okay, thank you very much, Andres. Now is going to be present Endica Blanco. The floor is yours. And please try to adjust the time because you didn't see us to say you have 1 minute left. If you can have your own clock, it's perfect.
Hello. Good evening, everyone. Can you see the presentation? No? A moment.
Yes.
Now?
Yes. Yes. Okay. Perfect. If you put it in full screen.
No.
Perfect.
Okay. Thank you. Well, I'm Enrique Blancurdillo. I am doing my PhD in ICI4, Madrid, about the molecular response to grafting, analyzing the genotypes of Pinus pinaster with contrasting draft response. First, I have to say that this PhD is part of a larger project that aims to learn more about the mechanism behind the response of conifers. In this case, Pinus pinaster, to which the effect of water stress and the communication of this response between organs, for which grafting is a key methodology that we use. However, my PhD is focused on improving the understanding of the response of Pinus pinaster to the stimuli of grafting. First, I'll explain briefly what grafting is. Graft is composed in two parts: the needle, a tissue originated from another individual or another part of the same individual, that is attached to an already settled individual, the rootstock.
Excuse me, Enrique.
Grafting is the operational. Sorry?
We didn't see your presentation move. Sorry. You are sharing your screen, but this is not moving.
Okay.
Sorry. You can start again. The cat is also interested.
Okay. Now?
Yes. Yes. Okay. Sorry. Now.
Okay, sorry. Well, the grafting traditional used have been primarily used as vegetative propagation method in agriculture in order to enhance the production of fruit or wood, for example, taking advantage of the features of the rootstock, like more resistance to climate or pathogens. Nowadays, however, grafting is also used as methodology to study the communication between different organs. Well, in order to study the water stress, the project works with well-genotyped and phenotyped individuals of Pinus pinaster, which are GAL 1056, native from the northwest of the peninsula, lives in a wet climate and has a great growth, and Oria 6, native from the southeast of the peninsula, lives in a wet climate and a dry climate and has a limited growth. And then we have the progeny of these two individuals, and from them we taken the most tolerant and the most sensible to water stress in order to do further studies. As I said before, in order to understand the communication of the response to water stress between the organs, the grafting methodology is used, and my PhD is focused on understanding and separating the effect of grafting from the effect of water stress. In order to achieve that, we use three grafting methods: not grafted, which we use the progeny not grafted, the progeny self-grafted, and the progeny rootstock grafted with GAL 1056. Then we applied that methodology to both the most tolerant and the most sensible of the progeny, and we taken a sample from needle, science stem, rootstock, and root. Then we extracted the messenger RNA from the samples and built a de novo assembly transcriptome. We use BLAST Interpro scan, and EGNOG mapper for annotation and functional characterization, and worked with DSEC to analyze the transcriptome data in order to identify which genes are involved in the response to grafting. Within the preliminary results, we have the PCA just to check which variables have more strength in the variance of the data, which are primarily the genotype and secondly the variant, the organ. Then we made a differential expression analysis from which we extracted the differential expressed genes for grafting, comparing primarily not grafted versus autografted. And also we made through a weighted co-expression network analysis, we identified which genes modules are correlated with each of the grafting types that we studied. And that's what's done until now, but there's a lot more to do. A complete functional characterization of genes due to the lack of characterization of the genes in conifers, and analysis of small RNA profiles, and analysis of hormone profiles. Thank you. I hope that I've been in time.
Thank you, Indica. Very interesting work. So now is going to talk Maria González.
Hi everybody. Just let me know if my presentation is working.
Yes. Yes, perfect.
Okay, perfect. My name is Maria González Granados, and I am a PhD student at EC4 INEA. Today I'm going to present one of the chapters of my PhD, which we call The Other Phase of Recovery, a review of the human dimension of Europe's returning large carnivores. So, the return of Europe's large carnivores offers an unprecedented opportunity for trophic restoration. However, its success depends not only on ecological conditions, but also on human acceptance, because the interactions between human and wildlife are also increasing. So, understanding how social aspects are addressed across Europe is essential to anticipate challenges and guide restoration strategies. With that in mind, our objective was to systematically collect empirical studies addressing the human dimension of large carnivores in a restoration context in the last 25 years. So for that, we were interested in taking as case studies articles in which they have performed or conducted primary work. That means questionnaires or interviews or co-method about attitudes or tolerance or perceived benefits of large carnivores in restoration context. And I will explain. We were interested in knowing what was the general trend of these attitudes or tolerance among different stakeholders, for example, farmers or hunters or rural people. And of course, the other main characters of our case studies were the large carnivores in Europe. So these questionnaires or interviews had to be about any of these 5 large carnivore species in Europe, that is wolf, brown bear, wolverine, and the 2 lynx species, Eurasian and Iberian lynx. In addition, we were interested to know how was the ecological restoration context addressed in these social studies. So it has to be a recovery context of the large carnivore population toward an original ecosystem or toward an alternative ecosystem in which we could, or there could be any type of coexistence between large carnivores and local people. So we we organize these case studies in a gradient of restoration approaches with different species, species and complexity, thinking about ecosystem structure. Our selection process was something like this. We look in the main database for scientific papers, that is Scopus, Web of Science, etc. And we started yielding more than 5,000 records. And after a process of title, after screening, full reading, etc., we yielded 260 case studies. What are our general conclusions about the general trends of this type of studies in Europe? So let's take, for example, wolf and brown bear. Here in this map, we located the case study with these dots. And we were especially interested to know how was the restoration context around this case study. So here in the map, you can see the light color. It means the distribution that the species is supposed to have had in the 18th, 19th century. Then the darker line is the population range at its minimum, that is in the 1960s, 1970s. And then the darker color for both maps is the current distributions. So our conclusion with this part of with these results was that wolves are the most studied species, followed by brown bears. And species are especially located in Northern Europe and Scandinavian countries and Central Europe, despite many areas in Southern Europe where the species has been present, let's say, permanently, which have not been studied yet. Also, our analysis reveals that research on human dimension of carnivores has increased over time. However, there are few studies adopting longitudinal approaches, and with that we mean that they have conducted a questionnaire or an interview, and then they have about attitudes, let's say, for example, about the wolf, and they have come back after some years to see how these attitudes have evolved during this period of time. However, we found that this was not very frequent. In addition, also few studies adopt cross-border approaches, despite many populations in Europe spanning multiple countries. Among our case studies, passive restoration intervention predominated, especially conservation policy, which included that means that in the case study they mentioned that the species was legally protected, or they have in the country they have performed any kind of management to persecute illegal killing, for example. But it was also quite often that they mentioned that the species has recolonized the area naturally. On the other hand, active interventions were very scarce and only focused on brown bear and lynx species. But it was not for the other species, for wolverine or for wolves. And just a few ideas to take home. I would like to say that human dimension research is species bias, as we have seen, especially toward wolves. Also, that longitudinal and cross-border approaches remain scarce, and that is a limitation for future management, because attitudes is not something fixed, it's something that evolved in the time, and it's interesting to know how the perception of the people change toward the species when the density of wolves, for example, increases or decreases. And also that it's important, yeah, to collaborate between countries, especially if they are sharing the same carnivore population. In addition, studies predominantly address passive restoration contexts with limited attention to active restoration. And just as a final general conclusion, I would like to emphasize that social acceptance is critical determinant of successful ecological restoration in the long term. Thank you very much for your attention.
Well, thank you very much, Maria. Now we continue, not online. You please still there, listening our partners. So now is going to talk Diego.
So, hello, thank you everyone. Good evening, I am Diego and I will be talking about the impact of climate change on the European beach distribution and its convergence with the Natura 2000 network. For those who don't know, the Natura 2000 network is the primary network of preserved areas here in Europe. In Fagus Silvatica, the European beach, I think for me at least proves a dual role. Not only it has a great timber value, but it also provides habitat for many species of great interest for conservation. So with this objective, we created these research questions. The first one about the historical change in distribution of these species, Fagus Silvatica. The second one looking into the key climatic factors that significantly influence this distribution. And the last one, what do the future scenarios says about these changes in the distribution and how does this converge with the Natura 2000 network? To answer these questions, we follow the Prisma 2020 methodology, a literature review with a general literature search in the principal scientific repositories such as Scopus or the Web of Science, searching for keywords like Fagus Silvatica distribution, climate change, whatever. And with that, we obtained 131 initial records with 91 unique studies, and then we filtered them by the title and abstract, and then we did a full text evaluation, including this in the final study. So, answering the first question about the historical change in distribution, the literature converges in three clear patterns. In the most warm and dry margin, so maybe like the Mediterranean regions or the Iberian Peninsula, it has been seen a decline in vigor and displacement driven by competition. And in the mountain regions, it has been seen an upward shift towards higher elevation, looking always for for more humid areas and better temperatures for the species. And the thing that I took more interest was the northern margin, that contrary of what you may expect, there hasn't been a generalized northward expansion, and this is maybe because of the edaphic conditions and the competition with local species. And I say that because there has been seen some local expansion, so there is difference in the northern margin. The climatic factors, we all know them. The rising temperatures, the changing in the precipitation cycles, summer droughts, etc. Mean and maximum temperature has an effect in the reduction in the secondary growth, which is the radial growth of the trees, and also a disruption in the masting process, so the reproductive. But the water deficit is the most key climatic factor, so, like you can see in this image, where the blue areas show us where the precipitation is more common, there is more water available, and the arrows show us the increase or decline in the basal area. So this water deficit has forced migration towards more humid area, and with adding the rising temperatures, we are seeing some progressive replacement with more tolerant species. Both these factors cannot be separated from the edaphic factors or the intra and interspecific competition. So the future scenarios follow the same trend. Retreat in the warm margin, there is no generalized expansion in the north areas, and it has been seen, and it hasn't been seen because it is in the future, but a shift towards more high elevations. So putting this side by side with the Natura 2000 network, there isn't a lot of studies that look into this specifically, but those that do show what we may expect also. There may be some increases in the distribution in the places that accommodate better these species, like the alpine regions or boreal, and in the Mediterranean basin, where there may be some losses. So what could we project to or provide to the management? ¿Qué estoy diciendo? So for the projected representativeness of beads within the Natura 2000 network, we have to assure that there is some attitudinal and edaphic diversity in the sites, but also connectivity between these protected areas, so we can facilitate the migration from one side to another. Concluding this presentation, I want to highlight these ideas that the change in beach distribution is primarily driven by the water deficit, and this has been proven by some clear declines in the dry and warm margins, but the mountain and north regions act like a refuge. The projections continue with these trends, and the effectiveness of the Natura 2000 network will always depend on the capacity of the institutions to adapt to these changes and basically listen to what the scientists say. Thank you very much.
Thank you very much, Diego. You read a lot of papers to doing this. Thank you for that. So the next speaker must be Laura. Laura.
good afternoon. I'm Laura Daniela Garcia, and I will expose you a short literature review. And named Mangroves of South America and their effects due to climate change. Mangroves. A mangrove forest is composed for halophytic vegetation, day trees in transition zone between freshwater of rivers and saltwater of the sea. These trees are adapted to saline environment, with the roots are partially or completely submerged. Mangroves have aerial roots known as prop roots, which provide support in muddy soils and facilitate gases exchange, especially during tide heights. What is the importance of these ecosystems? Well, natural nurseries, coastal defense, water filters, and they call it the lungs of the planet. Globally, mangroves cover approximately 150,000 square kilometers. In South America, the estimated area is 16,500 square kilometers. It's covered about 11% of the world total. The ecosystems are distributed along the Pacific, Caribbean, and all coast Atlantic Oceans. How I was saying, this systematic review was conducted to synthesize the information, evidence available online when talk about mangroves of South America, published between 2015 and 2020. This process followed RISMA guidelines. After cleaning, isolating all documents, the compiled information was organized in 4 thematic categories: mangroves and climate change, anthropogenic impacts, extension of mangroves, and mangroves mitigation and conservation strategies. Mangroves are important for their high carbon sequestration capacity, which can be up to 5 times more than the other forests. For this reason, they are considered one of the ecosystems with the greatest potential to climate change mitigation. Globally, mangroves can store approximately 11 billion tons of carbon. The structure and the vegetation of mangroves are linked to interact with the climatic and environment and biogeochemical factors. Soils plays a fundamental role in carbon and nutrient cycles. Furthermore, soil respiration can be affected by variation in humidity, soils acidic temperature, and as well by change in hydrological dynamics. Mangrove mortality can increase more carbon by dead matter and also increase greenhouse gas emissions like methane and CO2. For that reason, under climate warming scenarios, mangroves can be transformed from carbon sinks to net source of carbon emissions. The extent of mangroves exhibit marked spatial and temporal variability, determined by interaction with climate and oceanographic factors, as well various anthropogenic activities. As of 2020, in South America countries with the largest mangrove areas were Brazil with 11,414 square kilometers. Second, Venezuela with 2,846 square kilometers, and the third, Colombia, 2,807 square kilometers. Also, expansion has been recorded in some regions. Mangroves remain one of the most threatened ecosystems globally. Recent losses are particularly significant considering that deforestation of this ecosystem contribute approximately 10% of the global carbon emissions by the land use change. Anthropogenic effects, well, the most impacts that suffer this ecosystem is for anthropogenic impacts like wood extraction, urban and tourist expansion, expansion for the agricultural frontier or aquaculture activities. This ecosystem will suffer severe pressures for the humans. In well-preserved mangroves, the rates of nitrogen and phosphorus accumulation and sediment growth are significantly lower than in those exposed to urban effluents or aquaculture activities, where nutrient deposition can be up to 20 times greater. This demonstrates that the direct impact of human activities on the biogeochemical process of the ecosystems. One of the most well-documented conservation strategies for mangrove ecosystem is ecological rehabilitation or restoration. In South America, efforts have focused primarily on rehabilitating hydrological and sedimentary processes rather than on the mass planting of species. Several studies in neotropical regions indicate that effective restorations depends on the recovery of hydrological connectivity, sediment availability, and the switchability of local conditions. These factors favor the natural regeneration of species, increase their survival rates, and strengthen the ecosystem resilience to climate change. Also, the combination of strategies based on natural restoration processes, blue carbon conservation, participatory governance, and the implementation of effective public policies constitutes a comprehensive approach to ensure the persistence of mangroves in the face of the changing goals. Well, the evidence shows that the structure, function, and composition of mangroves are profoundly influenced by processes associated with global change. These ecosystems fulfill essential ecological functions such as coastal protection, carbon storage, and biodiversity support, and also possess high social and cultural value for coastal communities, who have or historically depend on them for their substance and well-being. In this context, it is crucial to integrate mangroves into coastal management, conservation, and climate action strategies. The persistence of these ecosystems will depend on the implementation of adaptive approaches that recognize the ecological, social, and economic value, along with the effective reduction of anthropogenic pressures that compromise their integrity. Thank you.
Thank you, Laura. So our next speaker is Marina.
Thank you and good evening. Today I'm presenting our work on adaptive management framework to improve fishway performance. This study, conducted by the GEA group, focuses on how technology and real-time data can help us overcome the limitation of traditional static river management. River fragmentation is a critical threat to aquatic biodiversity. The main issue is that most fishways are designed as static structures. We build them based on theoretical conditions and then we forget them, the build and forget approach. But rivers are dynamic. And these structures often fail because they cannot adapt to environmental variability. We conducted our research at the Duero River in Vado Condes in Burgos. We work at the runoff river plant with a 3.75 meters head. This is a perfect case study because the plant's operation directly affects the water levels available for our target species, that is the Iberian barbel. And to monitor the site, we deployed a low-cost IoT sensor network. First of all, we installed water level sensors to track real-time hydraulic conditions. For biological tracking, we use infrared fish counters and pit tag antennas. We tag over 1,100 fish to verify complete access through the fishway. Here, a multi-parametric probe was added to record environmental triggers like temperature and luminosity. And all sensors are connected via hybrid radio and cable infrastructure. And the brain of the system is a Raspberry Pi running Python algorithms. And data is sent to the cloud via satellite or GSM, allowing for remote and real-time management. Our methodology merges hydraulic, climatic, and biological records. We use edge computing for real-time data cleaning. The core of our analysis is a random forest model developed through recursive feature elimination supported by neural networks for autonomous event classification. Moving into our results, the random forest model achieved a high accuracy. As shown in the future important chart, we categorize the variables into two groups, climatic and hydraulic. This distinction is fundamental to understanding how the fishway performs. On this graph, we can see the role of the environmental factors. These act as triggers that determine when the migration happens. Factors like luminosity and water temperature that create the biological seasonal window, shown here by the Gaussian curve. This curve represents the period when fish are biologically motivated to move based on external cues. However, in this graph, reveals the critical impact of hydraulic regulators. While the climate triggers, the blue line, define the potential timing, the actual variation and magnitude of passive acid depends on the hydraulics. Now, how do we translate this model into a practical tool? So, this slide shows our predictive adaptive framework. First, we use forecasting, feeding environmental predictions into our model to estimate future performance. Then, our recursive optimization algorithm calculates the optimal values for the variables can actually control, like the water levels and sluice gate position. And finally, the system is self-learning, ensuring that the model adapts for long-term environmental shifts and climate evolution. The most practical application is regulating the sluice gate. As you can see in the graph, by reducing the hydraulic drop at the fishway exit, we found the potential 166% increase in fish passage efficiency. And crucially, this optimization does not require altering the hydropower plant's energy production. That is an important point for economic. And in conclusion, real-time hydraulic regulation is the missing link in fishways design. Our approach is affordable and scalable using IoT sensors, and by managing operation during peak biological windows, we can reconcile energy and ecology, meeting EU biodiversity 2030 targets. And that's all, and thank you.
Well, the next speakers has to be Ashma. I don't know how to say Ashma. Si quieres puedes usarlo en el curso para avanzar.
Hello everyone, so today I'm going to present my work entitled Land Use Mapping and Change Detection in the Granbelia region in Tunisia using Sentinel-2 imagery and machine learning. So to start, we all know that both land use and land cover are constantly changing due to factors such as farming practices and urban expansion. And it's monitoring these changes is essential for sustainable management, food security, and environmental planning. In this context, using satellites, Sentinel-2 satellite imagery combined with machine learning techniques constitute a powerful solution to produce reliable land use maps. So the problematic is to produce reliable land use maps and land use and land cover maps over time remains challenging because of the landscape complexity, the limited availability of ground truth data, especially for past years, and the spectral similarity between different crops. So the main objective was developing an effective land use classification methodology using Sentinel-2 multispectral imagery and machine learning techniques, but that was not the only objective. It was also to develop 3 classification methods to evaluate them and compare them. So for the study area is the Granbelia region in the northeast of Tunisia that covers an area of 372 square kilometers and which is known by its agricultural dominance such as citrus, cereals, olives, vineyards, vegetables, and it also includes Sabha, which is a lake, and spontaneous vegetation. To do this work for this study, I used Sentinel-2 L2A multispectral images, field truth polygons for the period of 2016-2017 and 2020-2021, and all this work was implemented in Python, and we used also QGIS and Google Earth. The methodology. First, Sentinel-2 L2A images were downloaded from the Copernicus Open Access Hub. For each 2 periods were analyzed, 2016-2017, 2020 and 2021. For each period, we downloaded images from November, January, March, and May. Then for each year, we did the stack of images to have a multi-temperature composite data set, an image composed of 40 spectral band. Next, we did the shapefile from ground truth samples. Each shapefile was divided in 70% training sample and 30% validating sample. Then 3 classification algorithms were applied, the random forest, the SVM, and the CNN, convolutional neural network. Then each model was trained independently and evaluated using the kappa index. We used also the user accuracy and the producer accuracy. Finally, land use maps were produced, were generated, and the best performing model was selected based on the highest kappa index. The results. Here, the slide shows the resulting land use maps produced by different classification algorithms. We have on the first line the results for the year 2016 2016-2017 for the different methods, and on the second line the results for 2021. So all the three methods were able to capture the general spatial patterns of land use in the study area. However, differences appear in the classification of smaller or less dominant classes. So, the random forest classifier achieved the highest kappa index, 0.984 for 2016-2017 and 0.977 for 2020-2021, outperforming CNN and clearly surpassing SVM. The CNN model performed well with the dominant classes such as citrus and olives, but struggled with minority classes. In contrast, random forest demonstrated a better balance between producer and user accuracies across all classes. So here is the graphical representation of the area of each class in hectares using the random forest. We can see the dominance of the citrus trees, olive trees, and build-up area. We see a reduction in citrus and olive trees for the year 2020-2021, and an increase in the spontaneous vegetation. This does not reflect only real land dynamic, but also classification errors. So we need to improve the classification accuracy, and we can achieve that by incorporating summer season imagery and vegetation indices to better distinguish annual crops from permanent tree cover. So to conclude, the study evaluated land use, land cover changes in the Grombelia region using Sentinel-2 imagery and the three classification approaches. Among them, random forest demonstrated the most robust and consistent performance, while CNN shows strong potential, especially for dominant land use classes. Although very good results were obtained, further improvements are still needed to better reflect real land use dynamics. And thank you.
Thank you very much. So our next speaker is Tightly. So now we are finishing, so you can prepare your questions. Okay.
Good evening. I'm Titli. I'm a made for master's student. Today I'm going to present on an experiment that I did during my master's thesis on agricultural botany. What motivated me to do this research was a huge global population expansion that is affecting the urban environment and degrading the urban environment. It's causing the emission of greenhouse gas, rising the temperature, and also creating urban heat island. In this graph, you can see how built-up area has been increased from 1989 to 2009, and the vegetation has been reduced in urban areas in Dhaka, which was my research area. In Dhaka, around 60% of total constructions is building area, and which is quite a threat to urban environment. Rooftop garden can be an effective tool to mitigate this urban environment degradation, as it can mitigate urban heat island effects, clean the air quality, and also increase biodiversity. During my research, I have used one plant growth regulator, that is gibberellic acid. It is found that gibberellic acid can increase the production of tomato during summer heat injury, and also it increases fruit setting in summer tomato. It increases its number of leaf per plant and number of branch per plant. Another element that I used in my experiment was silicon, which is a nutrient element for plant, and it enhances growth during abiotic stresses like heat, and it also increases the yield, increases the quality of summer tomato. So the objective of my study was to investigate the sole application of gibberellic acid, how they are affecting the morphophysiology and yield contributing character of summer tomato in rooftop garden, and also the investigating the effect of sole application of silicon, and to find out the best combination of application of gibberellic acid and silicon so that they can mitigate the heat injury in summer tomato production in a rooftop garden. The experiment was conducted in the rooftop garden of Department of Agriculture Botany of Sher-e-Bangla Agriculture University, which is located in Dhaka, Bangladesh. And the experimental period was from June 2016 to October 2016. As planting material, I have used summer or hybrid tomato variety. The different combinations of treatment that I used was first of all the control condition, and 20 parts per million gibberellic acid. Another one was 0.4 millimolar silicon application, and the fourth one was combined application of gibberellic acid and silicon. These are some of the parameters that I considered during my research, and I have included some morphological, some physiological, and some yield contributing and yield characters. I would like to share some of the results from my experiment. First of all, the plant height. The plant height was highly affected by the gibberellic acid. It was increased by it, but it increased more than the application of silicon. But when I combined the application of gibberellic acid and silicon, the plant height was highest. Next, the number of leaves per plant was found highest during combined application of gibberellic acid and silicon. I have conducted or collected spade value during 3 phases, that's 40 days after transplantation, 50 days after transplantation, and 60 days after transplantation. I'd like to focus on 50 days after transplantation, as during that period I have got the highest spade value. And although silicon increased the spade value, gibberellic acid increased more the spade value, and spade value was highest in case of combined application of gibberellic acid and silicon. However, I collected the data from another morphological character, that is leaf water loss, and found that silicon has reduced the leaf water loss in highest amount, and gibberellic acid increased the leaf water loss even more than the control condition. And when I use the combined gibberellic acid and silicon, the leaf water loss was reduced. Another important characteristics is the number of flower cluster per plant, and when I collected the data, I found that the combined application of gibberellic acid and silicon has increased number of flower cluster per plant. Individual fruit weight was collected, and it has been observed that gibberellic acid increases the fruit weight. Silicon although increases the fruit weight, but it's much lesser than gibberellic acid, and the highest fruit weight was found from gibberellic acid and silicon on application, and that is 17.43 gram. Finally, the fruit yield per plant, and highest fruit yield per plant was found from combined application of gibberellic acid and silicon, and that's 159 gram. To conclude, it can be said that the application of gibberellic acid has increased the summer tomato production in a rooftop garden. Also, silicon increased the production, but it was much less than the application of gibberellic acid. And the combined application of gibberellic acid and silicon provided the highest fruit yield per plant. It can also be said that the combined application of gibberellic acid and silicon can mitigate the heat injury in a rooftop garden for summer tomato production. I'd like to recommend, based on my experiment, that repeated trials are needed in rooftop garden to increase production, and experiments can be done to in a different variety and also in different seasons, and there is a high scope to conduct research in advanced experiment that how gibberellic acid combinedly with silicon is increasing the yield of tomato. These are some of the references that I have used during my research. Thank you so much for your patience.
Well, thank you very much, everyone. Also the online people. I hope you there. So nice time if you have forces to make questions. I know it's late and always is tired, but come on. Thank you very much for dynamize always this session. I'm trusting you.
Hello. First of all, I would like to congratulate all the presenters. I have just some simple questions. For Garcia. No, Diego. You did a study based on literature review. Okay, and you said that there are some projections that have been made in the future concerning the impact of climate change in Europe on Natura 2000, and they would like to know if what was the methodology that have you find in these different papers, which kind of methods they have been applied to do this projection in the future.
Hello? Yes? Okay. So thank you for the question. Yes, the projections and its convergence to the Natura 2000 were, I think, the most very simple, I guess. The authors projected like any other study with the different scenarios. Mainly the moderate and severe, and then you create the images and you just cut them with the shape of the Natura 2000 network, and you have the results. Yes.
That it was based on the ICCP models, I think. Yes.
Sorry?
It was mainly based on ICCP models that have been developed by the ICCP.
Yes, So every author obviously used some not his own methods, but generally the same, and they all pretty much concluded the same. So yeah, the tendencies were homogeneous between all the literature.
Another question for Daniela Garcia. Working on mangrove, you said that deforestation of mangrove contribute approximately 10% of the impact of climate change. Have you been able to find this in all your reading or in some of them?
I found that information in different papers. I don't conclude just for reading.
one question for Marina. Yes, I appreciate your work using IoT to find and to determine the influence of some variables on fish waste. And you said that the environmental variables were the most effective on this, how to say, this finding. Which from these environmental variables are the most effective?
I think they are like correlated because here in Spain, for example, luminosity is like a variable that is really correlated with the temperature because it's in the same season that they have both conditions in a high level. So, yeah.
This is the most important one.
Yeah. The luminosity time, how much hours they have of luminosity, and here it is correlated with the temperature of the water because it's in summer.
Last question for Titi, or influence of gibberellin acid. When you first presented the city, I was thinking that you are going to discuss about geography or something like this, or architecture, but you were presenting the effect of gibberellin and silicon on the fruit production. And you tried to relate this to the roof garden and their effect on reducing the impact of climate change and how to say temperature, mainly temperature. Your finding was good considering that they influenced the fruit production, but I wonder if in your country, in the city you presented, all the city, they are using these roof gardens, and if not, in how percentage, and if yes, how they are established in this roof, and what is the how to say the effective effect of this roof garden on this kind of climate change variables?
For your question. When I did the research, it was 2016, and back then, rooftop garden was not that famous in Bangladesh, in Dhaka. But right now, after all these years, and after doing researches on rooftop garden, which is increasing in number, and public training was given, it has increases its popularity, and people are liking it as a aesthetic value and also as a production quality. So yes, it has been increased since then, right now, and although there's, I would say it has a long way to go, because in a mega city like Bangladesh and Dhaka, rooftop garden has a huge potential to defend the environmental degradation and also to promote sustainable urban agriculture, to develop urban rooftop farming. So I would say we are in the middle of journey. We have a lot to do and achieve.
Hello everyone, congrats on your presentations. I wanted to ask Andres, that is the presenter from the other side. I was wondering about how you selected the drought events, because for me, I read a paper that said that the best way to select the drought events were using the SPAY, but with in August and with 6 months, with a 6 month period. And I seen your work, and I was wondering why you choose that that SPAY index.
Yes, can you hear me?
Yes.
What we did was to calculate all the SPI for 1 month, 2 months, 3 months, etc., for all the months, and then we did a correlation matrix between the tree ring width and the SPI. So the SPI that was more correlated with the fluctuation of the tree ring width was the one that we selected, and we selected the 16 month of December that captured all the climatic variability from the year and another 4 months of the previous year. And that's
Great. Now you leave me with more doubts than the answer, but I appreciate your ideas.
Thank you.
I have a quick question for you also, Andres. Because your studies in Lubia, near Soria, I live there. I wonder what is the surface of your plots? I don't know if you mentioned it, but I missed that. If you have 3 plots, I understand a triplet, 3 plots, but what is the size of the plot? Just for curiosity.
Yes, it's less than, it's around 800 square meters, around there.
Okay. Maybe 16 meters radius, circular plots or something like that?
No, they are rectangular, yeah.
Okay. Okay. Next questions. We have 5 minutes already. We can conclude today. Are you happy? Everybody wanted to go out, right? Well, so maybe, I don't know if I have to say finished words or what? Clap all the contributors. Thank you very much for being here today.
Yes. Okay, so we are done for today. Thank you all the presenters. It's a really long day. So I hope see you all in the restaurant on the other side of the campus for dinner, for cold dinner, and to hang out. There will be also a little bit of wine, so it will be funny. Thank you all of you, and greetings to people online. Thank you to be there. See you tomorrow at 9, okay?